must see.
They should be the same, but I don't think they are.
Okay, Charlotte?
The graphs like the middle where it reaches 0, it's symmetrical, so like it would make sense for them to be the same amount of time.
Okay, Charlotte's on team C. She's actually using some evidence here. I like where your head's at. Go ahead.
On the way down, it doesn't have your push. It starts from 0, and it has to go like speed up more.
You mean it's basic?
It gets a head start on the way up.
Yeah.
But also has gravity
also
pushing
slow
it
down.
down on the wing, so like resistance.
So you're more time
On the way
on the way down,
on the way up.
on the way up.
Because it doesn't have your push on the way down.
No, it's more time on the way down. Because
Wait.
yeah. No, yeah. No, you're right. Your reasoning's right, but just it's more time on the way down because after it
Yeah.
changes directions, it has to pick up its own speed instead of getting the speed it got from you pushing it on the way up.
Okay. I like
Okay.
it. Bella, go ahead.
So like me and Sarah were talking. So then we were like, well, and Grace, she was in the conversation. And I just disagreed with Grace. So like on the way up, you're pushing it. So that's your force. But it also
Well, I pushed it before we started looking at it.
okay, yeah, whatever. So you're pushing it. But it also has to go. It's going against gravity because it's going uphill. On the way down, it does not have your force, but it has gravity's on its side and it's pushing it down. So I feel like it both has a force push it like either way, so it'd be equal. So it has something.
How do you know those forces are equal?
Well, we did that. Well, he does it because it depends how hard he pushes it one time or how slow he does it. So it's never gonna. You're not.
All right.
Yeah, laws of Newton.
Go ahead.
I don't know.
You know what the laws
Listening, please.
are?
Every action has an equal and opposite reaction.
Because I feel
okay.
like just watching it, I feel like it on the way back down, it feels shorter.
I feel like it has more speed on the way down.
I think it's the same. I'm going to secret intercede.
What's the deal with the camera?
Yeah, we're trying to figure that out.
Are you participating in like a study of like students? Are you studying us
Is
and
this
our
a social
conversations?
experiment?
It's reaction.
Okay, so Mr. Pettis, have you ever confirmed that it stops?
Girl, are we gonna be
Does it stop?
It depends how hard you push it.
For an instant. Well, that's what you said, right?
But I thought it's never zero.
Is it, are we able to visually detect whether it's more time on the way up or more time on the way down?
Oh my God.
It's the same. That's my opinion. I was born.
So,
Well, it depends on
That
how
was
much
satisfying
time you give
and
it to
that's
it.
actually, so she said, why don't we measure it?
Yeah.
I spent years trying to
Stop
like
it from all the way
get
back.
stopwatches out, but the problem is that we know it stops at the top, but because it's moving slow at the top, there's no really great way to be like, I'm gonna like start one and stop, like it's really, it's
You
challenging
need
to
two
do.
people timing it.
And the error here is like 0.1 when you start a stopwatch and 0.1 when you stop it, so there's way too much error for like the 6 seconds it takes. What I want to do is, I want to argue from evidence given the graph. What is the shape of the position graph? It's a parabola. Is there a feature of a parabola that's going to help us understand this? All right, check with your neighbor now.
So it's
Check with your
the
neighbor.
same. It's secret
But I still don't know.
I'm not ignoring you. If I validate it right away.
Do you see that thing on the left? Do you see the thing on the left?
It's secret intercede because it's symmetrical.
Well, actually, time is.
No, it slows down.
I will start with straight.
I know, it's,
All right,
it slows down. So every time it goes up, you can't transfer the same amount.
what do we decide?
It's like a roller coaster. Two wheels can't be the same height.
Is there,
No, it won't. It won't. It does.
is there a feature of a parabola that's going to help us understand this? Okay? What's the feature of the parabola? Okay? Doesn't, I mean, if I draw this here, isn't this called the axis of symmetry?
But that doesn't mean that it takes the same amount of time to get there.
That's the
Well, that's
question.
just position.
True, but
Times the x-axis.
What has to be true about those if that's the line of symmetry?
It's like triangles.
Feet.
It's an isosceles triangle.
Do those have to be equal?
But it's not.
Like, we didn't measure the.
Yeah, it's not based on numbers, it's just like you drew it for like.
True. And you know what? You guys are actually going to experience this in the lab. Okay? You're going to actually experience this in the lab sometime coming up soon, so that we can get a good sense of it. But is this some reasoning we can at least say, maybe that makes some sense?
Yeah.
Is that cool? How about the real question? Okay? The next question is, if it leaves my hand going up this ramp at a certain speed, okay, when it gets back to me at the same position, do you think it's moving faster or slower? Okay? Why don't you check your neighbor on that one? Okay, do you think it's moving faster or slower when I catch it compared to when I let it go?
Okay, the Newton's cradle is an example of the transfer of energy. It has nothing to do with gravity.
It does have to do with the transfer of energy.
Potential
energy.
Yeah, have you not seen that potential kinetic energy graph?
I wonder if I can
Alright, watching please.
Now there's batteries in there.
So I let it go and it's moving a certain speed. When I catch it, is it moving faster or slower?
Same.
It's the same.
It's the same.
It's the same.
You think it's the same?
Yes.
Tell me why you think it's the same.
Symmetry.
Do you think you could like measure the sound, like when
I
it
was gonna
speeds
say
up,
I
it has
measure
a
by
different,
pitch.
like it has the same sound.
I like it. He says, if you just measure the sound, we could probably figure it out.
Sound of
Someone observing it?
Because like when it goes faster, it's a different sound.
Yeah, he's under.
But like I heard the
For the
same
bad
sound.
teaching.
Oh, you're right, it should make the